Imagine waking up on the morning of July 19th, 2024, and walking into this. Thousands of flights grounded globally, departure boards flashing red, travelers stranded as check-in systems completely locked up. The physical chaos immediately bled out from the airports into everyday life. Retailers couldn't process payments, and bank customers trying to withdraw cash were met with screens like this. Global commerce simply froze in place. When vital infrastructure fails this quickly and simultaneously across the planet, the initial conclusion is almost always the same: a highly coordinated nation-state cyber attack. Yet, as cybersecurity teams scrambled to trace the damage, they realized there was no invading hacker, no ransomware group holding servers hostage. Nobody had attacked the system at all. The entire global freeze was triggered by a routine, automated software update. It was pushed out by a highly trusted cybersecurity company called CrowdStrike. To understand how a single file brought the world's infrastructure to a standstill in a matter of hours, we have to look away from these physical spaces. We need to zoom deep into the invisible architecture of a single computer. The software in question is CrowdStrike's Falcon platform. This is an advanced threat detection system, constantly scanning for anomalous behavior to stop malware before it strikes. To do its job effectively, Falcon requires low-level access. It has to sit beneath the user interface, woven directly into the deepest foundation of the Windows operating system, the kernel. On July 19th, a microscopic logic flaw was accidentally pushed out through a routine update. It traveled straight past the Surface applications and injected directly into this deep Falcon module. Because this bad data hit the absolute lowest level of the system architecture, it triggered a critical failure before the upper layers of Windows could even attempt to boot up. The system broke itself trying to turn on. The immediate physical result of that broken foundation was millions of machines locking into an endless reboot loop. The operating system would try to load, hit the corrupt file, and throw the infamous blue screen of death. The very permissions required to protect the deepest, most vulnerable parts of a computer are exactly what gave a single, tiny coding error the ultimate power to instantly shut the entire machine down. Taking down a single laptop is an inconvenience, but modern critical infrastructure relies on massive interconnected server farms and thousands of enterprise-level machines to function. In these massive corporate environments, individual employees don't manually click Update. Security protocols dictate that millions of machines pull these protective files automatically and simultaneously, without any human review. This creates a massive hub-and-spoke network. Even though airlines, banks, and broadcasters seem completely separate, they all funnel back to a single central vendor for their endpoint security. This explains the terrifying speed of the fallout. A computer virus takes time to travel from machine to machine, but this flaw was pushed from the center, replicating itself worldwide almost instantaneously. That synchronized digital failure immediately paralyzed the real world. Routine surgeries had to be delayed, and emergency rooms struggled to access patient records because their vital systems simply ceased to exist. The July 19th incident mapped the true shape of global IT dependency. We often think of the internet as a resilient, decentralized web, but in reality, it operates as a highly centralized, fragile stack. Fixing the issue proved just as difficult as preventing it. Because the computers were crashing before they could load their operating systems, IT professionals couldn't push a remote software patch over the internet. The machines couldn't connect at all. The recovery required pure physical friction. Technicians literally had to walk to individual servers, laptops, and kiosks, boot them into safe mode, and manually delete the corrupted file, one machine at a time. The grueling pace of that recovery served as a massive wake-up call for governments and the tech industry. It exposed a staggering lack of systemic redundancy in how we build and deploy the software that runs modern society. We spent decades trying to build universal, bulletproof shields to protect our networks. In doing so, we connected nearly every critical system on Earth to the exact same vendors. The next time modern civilization suddenly halts, the cause might not be an adversary breaching our walls. It might happen because our defenses worked exactly as designed, leaving us all perfectly secured and perfectly vulnerable to a single line of broken code.